In this video, I'm going to show you how to use Raspberry Pi as I2C master. Do visit my previous video on how to build the Arduino Nano Rig if you haven't done so, because I'm going to reuse the same rig in this video. Before I begin, I wanted to give a huge shout out to Revox and the Duino Coin team for their tremendous effort in developing while maintaining the infrastructure, at the same time juggling between school and personal life. True to the open source spirit, I'm able to further develop this unofficial AVR miner for Raspberry Pi I2C. With that said, first, visit my GitHub page to download the zip file. Once uncompressed, open up the sketch. Go to the Duino Coin Wire tab and assign one device index for each Nano sketch upload. If you want to reuse the same sketch for all the Nano for mass update, you may comment out this line, but you need to make sure the Nano is able to handle the I2C address self-assignment flawlessly, so use this at your own risk. Next step is to SSH into the Raspberry Pi. Type in your password. The command is in the README file, so you can just refer to my GitHub page and copy the command and paste it into the terminal. To enable I2C on your Raspberry Pi, please visit this web page. It has the detailed instruction on how to turn on the I2C. After everything is done, it's time for reboot, so the changes will take effect. While rebooting, let's move on to the wiring of the I2C slave to Raspberry Pi. As you can see, I have pre-soldered the pin to the Raspberry Pi. This is the pinout image of the Raspberry Pi, so you may want to check your own pinout for your choice of single board computer. I have labeled all the wires so I can plug them in just by looking at the label. After double check all the wiring is correct, let's log in back to the Raspberry Pi. Using screen command, we can put the Python process into the screen session, so it can run in the background. Since this is the first time we run the miner, so there are a bunch of information that we need to key in. To detach the screen session, just use the keyboard combination of Ctrl A then D. To show you the screen session is still active, I logged out. I logged back into the Raspberry Pi. Using screen-R, I can restore the screen session. This is the periodic report that you can take a look at. If you display the pool info, which pool is the worker running on, and during the past 62 seconds, Nanos have submitted 281 shares that give us 4.5 shares per second, with the average hash rate of 183 hash per second. To automate the launching of the Python miner, we can use cron tab. Here I put in, at every reboot, if you put the Python miner into screen session, it is recommended to sleep for 10 seconds to let all the system process to be completed, then only restart the miner. It is possible to run PC miner simultaneously too, so not only the I2C slave is mining, the I2C master itself is also mining. Here is the comparison between ESP and Raspberry Pi as I2C master. The LED blinks more frequently on the right hand side. I feel Raspberry Pi is 4 to 5 times faster than ESP on number of submitted shares. More shares equal to more earning. This is the power consumption between ESP and the Raspberry Pi. As you can see, the difference in power consumption is not that big. Time to log in into the wallet. For each miner, we can see the submitted share, the rejected share, as well as the estimated earning. And that's the end of my video. If you think this is interesting and it helped you, do consider to donate DUCO to JK. Thank you very much to support me. Hit like, share and subscribe. See you next time.